Okay, so now that we've heard Scott talk about smart data fabrics, it's time to see this in action. Right now, we're joined by Jess Jowdy, who's the manager of healthcare field engineering at InterSystems. She's going to give a demo of how smart data fabrics actually work, and she's going to show how embedding a wide range of analytics capabilities, including data exploration, business intelligence, natural language processing, and machine learning directly within the fabric makes it faster and easier for organizations to gain new insights and power intelligent, predictive, and prescriptive services and applications. Now, according to InterSystems, smart data fabrics are applicable across many industries, from financial services to supply chain to healthcare and more. Jess today is going to be speaking through the lens of a healthcare-focused demo. Don't worry, Joe Lichtenberg will get into some of the other use cases that you're probably interested in hearing about. That will be in our third segment, but for now, let's turn it over to Jess. Jess, good to see you.
Hi, yeah, thank you so much for having me. And so for this demo, we're really going to be bucketing these features of a smart data fabric into 4 different segments. We're going to be dealing with connections, collections, refinements, and analysis. And so we'll see that throughout the demo as we go. So without further ado, let's just go ahead and jump into this demo, and you'll see my screen pop up here. I actually like to start at the end of the demo. So I like to begin by illustrating what an end user is going to see. And don't mind the screen because I gave you a little sneak peek of what's about to happen. But essentially what I'm going to be doing is using Postman to simulate a call from an external application. So we talked about being in the healthcare industry. This could be, for instance, a mobile application that a patient is using to view an aggregated summary of information across that patient's continuity of care or some other kind of application. So we might be pulling information, in this case, from an electronic medical record. We might be grabbing clinical history from that. We might be grabbing clinical notes from a medical transcription software, or adverse reaction warnings from a clinical risk grouping application, and so much more. So I'm really going to be simulating a patient logging in on their phone and retrieving this information through this Postman call. So what I'm going to do is I'm just going to hit send. I've already preloaded everything here. And I'm going to be looking for information where the last name of this patient is Simmons and their medical record number, or their patient identifier in the system, is 32345. And so as you can see, I have this single JSON payload that showed up here of just relevant clinical information for my patient whose last name is Simmons, all within a single response. So fantastic, right? Typically, though, when we see responses that look like this, there is an assumption that this service is interacting with a single backend system. And that single backend system is in charge of packaging that information up and returning it back to this caller. But in a smart data fabric architecture, we're able to expand the scope to handle information across different, in this case, clinical applications. So how did this actually happen? Let's peel back another layer and really take a look at what happened in the background. What you're looking at here is our mission control center for our smart data fabric. On the left, we have our APIs that allow users to interact with particular services. On the right, we have our connections to our different data silos. And in the middle here, we have our data fabric coordinator, which is going to be in charge of this refinement and analysis, those key pieces of our smart data fabric. So let's look back and think about the example we just showed. I received an inbound request for information for a patient whose last name is Simmons. My end user is requesting to connect to that service, and that's happening here at my patient data retrieval API location. Users can define any number of different services and APIs depending on their use cases, and to that end, we do also support full lifecycle API management within this platform. When you're dealing with APIs, I always like to make a little shout out on this, that you really want to make sure you have enough, like a granular enough security model to handle and limit which APIs and which services a consumer can interact with. In this Iris platform, which we're talking about today, we have a very granular role-based security model that allows you to handle that. But it's really important in a smart data fabric to consider who's accessing your data and in what context.
Can I just interrupt you for a second,
Yeah,
Jess?
please.
So you were showing on the left-hand side of the demo a couple of APIs. I presume that can be a very long list. I mean, what do you see as typical?
I mean, you can have hundreds of these APIs depending on what services an organization is serving up for their consumers. So yeah, we've seen hundreds of these services listed here.
So my question is, obviously security is critical in the healthcare industry, and API security is a really hot topic these days. How do you deal with that?
Yeah, and I think API security is interesting because it can happen at so many layers. So there's interactions with the API itself. So can I even see this API and leverage it? And then within an API call, you then have to deal with, all right, which endpoints or what kind of interactions within that API am I allowed to do? What data am I getting back? And with healthcare data, the whole idea of consent to see certain pieces of data is critical. So the way that we handle that is, like I said, same thing at different layers. There is access to a particular API, which can happen within the Iris product, and also we see it happening with an API management layer, which has become a really hot topic with a lot of organizations. And then when it comes to data security, that really happens under the hood within your smart data fabric. So that role-based access control becomes very important in assigning, roles and permissions to certain pieces of information. Getting that granular becomes the cornerstone of security.
And that's been designed in. It's not
Absolutely.
a bolt-on, as they like to say. Okay, can we get into collect now?
Of course. We're going to move on to the collection piece at this point in time, which involves pulling information from each of my different data silos to create an overall aggregated record. So commonly, each data source requires a different method for establishing connections and collecting this information. So, for instance, interactions with an EMR may require leveraging a standard healthcare messaging format like FHIR. Interactions with a homegrown enterprise data warehouse, for instance, may use SQL. For cloud-based solutions managed by a vendor, they may only allow you to use web service calls to pull data. So it's really important that your data fabric platform that you're using has the flexibility to connect to all of these different systems and applications. And I'm about to log out, so I'm going to keep my session going here. Therefore, it's incredibly important that your data fabric has the flexibility to connect to all these different kinds of applications and data sources in all these different kinds of formats and over all of these different kinds of protocols. So let's think back on our example here. I had 4 different applications that I was requesting information for to create that payload that we saw initially. Those are listed here under this operations section. So these are going out and connecting to downstream systems to pull information into my smart data fabric. What's great about the Iris platform is it has an embedded interoperability platform. So there's all of these native adapters that can support these common connections that we see for different kinds of applications. So using REST or SOAP or SQL or FTP, regardless of that protocol, there's an adapter to help you work with that. And we also think of the types of formats that we typically see data coming in as. In healthcare, we have HL7, we have FHIR, we have CCDs. Across the industry, JSON is really hitting the market strong now, and XML payloads, flat files. We need to be able to handle all these different kinds of formats over these different kinds of protocols. So to illustrate that, if I click through these, when I select a particular connection on the right side panel, I'm going to see the different settings that are associated with that particular connection that allows me to collect information back into my smart data fabric. In this scenario, my connection to my chart script application in this example communicates over a SOAP connection. When I'm grabbing information from my clinical risk grouping application, I'm using a SQL-based connection. When I'm connecting to my EMR, I'm leveraging a standard healthcare messaging format known as FHIR, which is a REST-based protocol. And then when I'm working with my health record management system, I'm leveraging a standard HTTP adapter. So you can see how we can be flexible when dealing with these different kinds of applications and systems. And then it becomes important to be able to validate that you've established those connections correctly and be able to do it in a reliable and quick way, because if you think about it, you could have hundreds of these different kinds of applications built out, and you want to make sure that you're maintaining and understanding those connections. So I can actually go ahead and test one of these applications and put in for instance, my patient's last name and their MRN, and make sure that I'm actually getting data back from that system. So it's a nice little sanity check as we're building out that data fabric to ensure that we're able to establish these connections appropriately. So turnkey adapters are fantastic. As you can see, we're leveraging them all here. But sometimes these connections are going to require going one step further and building something really specific for an application. So why don't we go one step further here and talk about doing something custom or doing something innovative. And so it's important for users to have the ability to develop and go beyond what's an out-of-the-box or black box approach to be able to develop things that are specific to their data fabric or specific to their particular connection. In this scenario, the Iris data platform gives users access to the entire underlying code base. So you not only get an opportunity to view how we're establishing these connections or how we're building out these processes, but you have the opportunity to inject your own kind of processing, your own kinds of pipelines into this. So as an example, you can leverage any number of different programming languages right within this pipeline. And so I went ahead and I injected Python. So Python is a very up and coming language, right? We see more and more developers turning towards Python to do their development. So it's important that your data fabric supports those kinds of developers and users that have standardized on these kinds of programming languages. This particular script here, as you can see, actually calls out to our turnkey adapters. So we see a combination of out-of-the-box code that is provided in this data fabric platform from Iris, combined with organization-specific or user-specific customizations that are included in this Python method. So it's a nice little combination of how do we bring the developer experience in and mix it with out-of-the-box capabilities that we can provide in a smart data fabric.
Wow.
Yeah, I'll
There's
pause.
a lot here. You know, actually,
I can
if
pause.
I could, if I
Yeah,
just want to sort of
please.
play,
Yeah, we
play
can
that back.
pause.
So we went to the connect and the
In
collect,
the collect
phase.
yes. We're
and
going into refine, so it's a good place
yeah,
to
so
stop.
before we get there, so we heard a lot about fine-grained security, which is
Yes.
crucial. We heard a lot about different data types, multiple formats. You've got the ability to bring in different dev tools.
Yep.
We heard about FHIR, which is of course big in healthcare.
Absolutely.
Right? That's the standard, and then SQL for traditional kind of structured data, and then web services like HTTP you mentioned, and so you have a rich collection of capabilities within this single platform.
Absolutely, and I think that's really important when you're dealing with a smart data fabric, because what you're effectively doing is you're consolidating all of your processing, all of your collection into a single platform. So that platform needs to be able to handle any number of different kinds of scenarios and technical challenges. So you've got to pack that platform with as many of these features as you can to consolidate that processing.
All right, so now we're going into refine.
We're going into
Let's do it.
refinement, exciting. So how do we actually do refinement? Where does refinement happen? And how does this whole thing end up being performant? Well, the key to all of that is this SDF coordinator, or stands for Smart Data Fabric Coordinator. And what this particular process is doing is essentially orchestrating all of these calls to all of these different downstream systems. It's aggregating, it's collecting that information, it's aggregating it, and it's refining it into that single payload that we saw get returned to the user. So really this coordinator is the main event when it comes to our data fabric. And in the Iris platform, we actually allow users to build these coordinators using web-based tool sets to make it intuitive. So we can take a sneak peek at what that looks like. And as you can see, it follows a flowchart-like structure. So there's a start, there's an end, and then there are these different arrows that point to different activities throughout the business process. And so there's all these different actions that are being taken within our coordinator. You can see an action for each of the calls to each of our different data sources to go retrieve information. And then we also have this sync call at the end that is in charge of essentially making sure that all of those responses come back before we package them together and send them out. So this becomes really crucial when we're creating that data fabric. And this is a very simple data fabric example where we're just grabbing data and we're consolidating it together. But you can have really complex orchestrators and coordinators that do any number of different things. So for instance, I could inject SQL logic into this, or SQL code. I can have conditional logic. I can do looping. I can do error trapping and handling. So we're talking about a whole number of different features that can be included in this coordinator. So like I said, we have a really very simple process here that's just calling out, grabbing all those different data elements from all those different data sources and consolidating it. We'll look back at this coordinator in a second when we introduce or we make this data fabric a bit smarter, and we start introducing that analytics piece to it. So this is in charge of the refinement. And so at this point in time, we've looked at connections, collections, and refinements. And just to summarize what we've seen, because I always like to go back and take a look at everything that we've seen, we have our initial API connection, we have our connections to our individual data sources, and we have our coordinators there in the middle that are in charge of collecting the data and refining it into a single payload. As you can imagine, there's a lot going on behind the scenes of a smart data fabric, right? There's all these different processes that are interacting. So it's really important that your smart data fabric platform has really good traceability, really good logging, because you need to be able to know, if there was an issue, where did that issue happen, in which connected process, and how did it affect the other processes that are related to it. In Iris, we have this concept called a visual trace, and what our clients use this for is basically to be able to step through the entire history of a request from when it initially came into the Smart Data Fabric to when data was sent back out from that Smart Data Fabric. So I didn't record the time, but I bet if you recorded the time, it was this time that we sent that request in. And you can see my patient's name and their medical record number here. And you can see that that instigated 4 different calls to 4 different systems, and they're represented by these arrows going out. So we sent something to ChartScript, to our health record management system, to our clinical risk grouping application, and to my EMR through their Fire server. So every request, every outbound application gets a request, and we pull back all of those individual pieces of information from all of those different systems, and we bundle them together. And for my Fire lovers, here's our Fire bundle that we got back from our Fire server. So this is a really good way of being able to validate that I am appropriately grabbing the data from all these different applications and then ultimately consolidating it into one payload. Now we change this into a JSON format before we deliver it, but this is those data elements brought together. And this screen would also be used for being able to see things like error trapping or errors that were thrown, alerts, warnings. Developers might put log statements in just to validate that certain pieces of code are executing. So this really becomes the one-stop shop for understanding what's happening behind the scenes with your data fabric.
That's your who did what, when, where, what did the machine do, what went wrong, and where did that go wrong? So
Exactly.
Right in your fingertips.
Right, and I'm a visual person, so a bunch of log files to me is not the most helpful, but being able to see this happened at this time and in this location gives me that understanding I need to actually troubleshoot a problem.
This business orchestration piece, can you say a little bit more about that, how people are using it? What's the business impact of the business orchestration?
The business orchestration, especially in the Smart Data Fabric, is really that crucial part of being able to create a Smart Data Fabric. So think of your business orchestrator as doing the heavy lifting of any kind of processing that involves data, right? It's bringing data in, it's analyzing that information, it's transforming that data in a format that your consumer is not going to understand. It's doing any additional injection of custom logic. So really your coordinator, that orchestrator that sits in the middle, is the brains behind your Smart Data Fabric.
And this is available today?
It's
all works?
all available today, yeah. It all works, and we have a number of clients that are using this technology to support these kinds of use cases.
Awesome demo. Anything else you want to show us?
Well, we can keep going. I have a lot to say, but really this is our data fabric. The core competency of Iris is making it smart, right? So I won't spend too much time on this, but essentially if we go back to our coordinator here, we can see here's that original, that pipeline that we saw where we're pulling data from all these different systems and we're collecting it and we're sending it out. But then we see two more at the end here, which involves getting a readmission prediction and then returning a prediction. So we can not only deliver data back as part of a smart data fabric, but we can also deliver insights back to users and consumers based on data that we've aggregated as part of a smart data fabric. So in this scenario, we're actually taking all that data that we just looked at and we're running it through a machine learning model that exists within the smart data fabric pipeline and producing a readmission score to determine if this particular patient is at risk for readmission within the next 30 days, which is a typical problem that we see in the healthcare space. So what's really exciting about what we're doing in the Iris world is we're bringing analytics close to the data with integrated ML. So in this scenario, we're actually creating the model, training the model, and then executing the model directly within the Iris platform. So there's no shuffling of data, there's no external connections to make this happen. And it doesn't really require having a PhD in data science to understand how to do that. It leverages all really basic SQL-like syntax to be able to construct and execute these predictions. So it's going one step further than the traditional data fabric example to introduce this ability to define actionable insights to our users based on the data that we've brought together.
Well, that readmission probability is huge,
yes,
right? Because it directly affects the cost for the provider and the patient. You know, so if you can anticipate the probability of readmission and either do things at that moment or, you know, as an outpatient perhaps to minimize the probability, then that's huge. That drops right to the bottom line.
Absolutely. And that really brings us from that data fabric to that smart data fabric at the end of the day, which is what makes this so exciting.
Awesome demo.
Thank you.
Fantastic.
Thank
People,
you.
are you cool if people want to get in touch with you?
Oh,
how
yes,
can they do that?
absolutely. So you can find me on LinkedIn, Jessica Jowdy. We'd love to hear from you. I always love talking about this topic, so would be happy to engage on that.
Great stuff. Thank you, Jess.
Thank you
Appreciate
so
it.
much.
Okay, don't go away, because in the next segment, we're going to dig into the use cases where data fabric is driving business value. Stay right there.